In this tutorial, we'll learn how to clean and prepare data using the Pandas library in Python. The first step is to import the Pandas library, usually with the alias pd, and then read the raw data from a CSV file. Pandas provides the readCSV function, which makes it easy to load datasets into a data frame for further cleaning and analysis. After loading the dataset, we can use the df.info function to display important information about the data frame. This includes the number of rows and columns, column names, data types, non-null values, and memory usage. It helps us quickly understand the structure of the dataset and identify potential cleaning issues, such as missing values or incorrect data types. Next, we can use df-isNull_sum to check for missing values in the dataset. This command returns the total number of null or missing values in each column, helping us identify which parts of the data need cleaning or further attention before analysis. Using printf columns displays the names of all columns in the data frame. This is useful for understanding the dataset structure, verifying column names, and identifying any spelling issues, extra spaces, or inconsistent naming that may need to be cleaned. One of the first and most important steps in data cleaning is standardizing the column names to make the dataset more organized and easier to work with. This usually involves removing unnecessary spaces using string methods like strip, converting all column names to lowercase for consistency, and replacing spaces or special characters with underscores. Clean and standardized column names improve code readability, reduce errors, and make it easier to access columns during data analysis and pre-processing. After cleaning and standardizing the column names, we can use printf columns again to verify the changes. This allows us to confirm that all column names have been properly formatted, with unnecessary spaces removed, text converted to lowercase, and spaces replaced with underscores for consistency. Next, we remove duplicate rows to ensure the dataset does not contain repeated entries that could skew analysis results. We can first check how many duplicate rows exist using df-duplicated_sum, which returns the total number of duplicated records in the data frame. If duplicates are found, we can remove them using df-drop_duplicates, keeping only unique rows. This step helps improve data quality and ensures more accurate analysis. We also check for missing values in the dataset using df-isNull_sum. This function shows the total number of null missing values in each column. Identifying missing data is an important step because it helps us decide whether we need to fill, remove, or otherwise handle incomplete records before continuing with the analysis. After identifying missing values, we focus on handling them in specific columns such as age. For example, we can fill missing values in the age column using the average value with dfig, fill_nadfig, mean, in place equals true. Next, we also need to check for invalid data in the same column. This includes values that do not make sense, such as negative ages or unrealistically high values, for example, above 100. We can identify these issues by filtering the dataset and counting them, which helps us understand how much data is affected. By combining these steps, filling missing values and detecting invalid entries, we ensure that the age column is clean, consistent, and suitable for further analysis. Next, we handle missing values in categorical columns such as hobbies. Since text-based fields cannot be replaced with numerical statistics like a mean, a common approach is to fill missing entries with a placeholder value such as unknown. We can do this using hobbies, fill noun, in place equals true. This ensures that no values are left empty and that the data set remains complete and consistent for further analysis. Next, we handle missing values in the skill level column, which is a categorical feature. Since skill levels are labels rather than numbers, a practical approach is to assign a default category such as beginner to any missing entries. We can do this using skill level, fill_beginner, in place equals true. This ensures that all records have a valid skill level and keeps the dataset consistent for analysis and modeling. Next, we handle missing values in the name column. Since names are identifying labels, we can replace any missing entries with a placeholder such as anonymous to ensure every record has a value. We can do this using name, field anonymous. Setting in place equals true applies the change directly to the data frame. This step helps maintain consistency and avoids issues caused by empty name fields during analysis. The next step is to filter the dataset to keep only valid and relevant age values. We can use a condition on the age column to retain records where the age is within a realistic range, for example between 1 and 100. This can be done using Boolean filtering in Pandas, such as df equals diffage equals 1 and diffage equals 100. By applying this filter, we remove unrealistic or invalid age values like negative numbers or extremely high values. This ensures the dataset contains only clean and meaningful records for analysis. Next, we clean the hours per week column by removing any invalid values. Since working hours cannot be negative, we filter the dataset to keep only records where hours per week is greater than or equal to 0. This can be done using a condition like df equals df hours per week equals 0. This step helps eliminate incorrect or corrupted entries and ensures that all remaining values in the column are realistic and suitable for analysis. To further clean the dataset, we can remove extra leading and trailing spaces from text values. This is important because unwanted spaces can cause inconsistencies when filtering, grouping, or comparing data. We can fix this using the strstrip method in Pandas. For instance, if name equals name, strstrip removes extra spaces from all values in the name column. Next, we standardize the email column to ensure consistency across all records. Email addresses should follow a uniform format, so we convert all text to lowercase using strlower and remove any extra leading or trailing spaces using strstrip. By applying these transformations, we ensure that email values are clean, consistent, and free from formatting issues that could affect searching, matching, or validation during analysis. Next, we standardize the values in the hobbies column to make the text data more consistent and readable. Since users may enter hobbies in different formats, like all lowercase or all uppercase, we can convert them into title case, where the first letter of each word is capitalized. We can do this using strtitle, for example, hobbies equals hobbies, strtitle. This step helps ensure that all hobby names follow a uniform style, making the dataset cleaner and easier to analyze or group later on. To validate the email column, we can check whether each value contains the @ symbol, which is a basic requirement for a valid email format. This helps us identify clearly invalid entries before further processing. This keeps only rows where the email contains @ helping to filter out obviously incorrect or malformed email values and improving overall data quality. Next, we can improve email validation by using a more accurate check with regular expressions instead of only looking for the @ symbol. This allows us to filter out emails that are not properly formatted, for example, missing domain names or containing invalid characters. In Pandas, we can use strcontains with a regex pattern to keep only valid-looking emails. This step helps remove invalid email entries more reliably and ensures that the remaining data follows a standard email structure, improving the overall quality and usefulness of the dataset. Next, we can standardize the age column by rounding its values to a consistent format. This is useful if the age data contains decimals and we want cleaner, whole number values for analysis. We can use the round function in Pandas, for example, df age equals df age round 1. This rounds each age value to one decimal place, helping maintain consistency in the dataset while still preserving a reasonable level of precision. After filtering and cleaning the dataset, the row indices may become unordered or inconsistent. To fix this, we reset the index so that it starts from 0 and follows a clean sequence. This is done using the reset index method. For example, df equals df reset index drop equals true. The drop equals true parameter ensures that the old index is not added as a new column in the data frame. This step helps keep the dataset neat and properly structured after all cleaning operations. Finally, after completing all the data cleaning steps, we save the cleaned data set to a CSV file, so it can be used later for analysis or modeling. When comparing the raw and cleaned data, we can see many improvements. The raw dataset had missing values in columns like age, hobbies, hours per week, and skill level. as well as invalid ages and inconsistent email formats. After cleaning, missing values were filled, invalid entries were removed, and text fields were standardized. Overall, the dataset is now cleaner, more consistent, and ready for analysis. You have successfully completed the Pandas data cleaning tutorial. Now you know how to load raw data, inspect it, handle missing values, remove duplicates, fix invalid entries, standardize text fields, validate emails, filter data, and finally save a clean dataset ready for analysis.